Okay, let's do like a couple definite integrals. Okay, so if I want to evaluate this one, I'm going to take the antiderivative, use the fundamental theorem of calculus. So the antiderivative of x squared plus 2x minus 5, x cubed over 3, plus 2x squared over 2 minus 5x. I'm going to evaluate that from 1 to 3. Now you might realize I don't need this 2 and this 2 here, but I just wanted to show you that's the constant multiple rule. The 2 comes along for the ride, and then we take the antiderivative of x to the first, add 1, divide by the new power. Okay, but you might see that the antiderivative of 2x is x squared. So now I'm going to find the value of the definite integral by plugging in 3 and then subtracting and plugging in 1 using the fundamental theorem of calculus. So that's 3 cubed over 3 plus 3 squared minus 5 times 3. Minus, and then I plug in the 1. 1 cubed over 3 plus 1 squared minus 5 times 1. So that should give me 9 plus 9 is 18 minus 15, 3 minus, and what is this going to be? 1/3 plus 1 minus 5. So my answer should be, and you could save yourself some trouble, use a calculator maybe. That's going to be 4/3. 1/3 plus 3/3 is 4/3 minus 15/3 is 11/3, I believe. Make that a 3, make that a 9. I think it's 20/3. How about the next one? So this is a product of two functions. We don't have a product rule for these guys, but first I'm going to distribute, right? So I get 7t to the 1/2 minus t to the 3/2. Evaluate. So I'll rewrite it first, right? And then I will take the antiderivative, and I should get 7t to the 3/2. If I add 1 to 1/2 times 2/3 minus t to the 5/2 times 2/5, 0 to 4. So that's 14. It's 14 over 3. Plug in my upper bound of 4 to the 3/2 minus 2/5, 4 to the 5/2. And remember, this is the square root raised to the 3rd power. So 4 to the 3/2 is the square root of 4, which is 2, cubed, which is 8. So I got 14/3 times 8 minus square root of 4, which is 2 to the 5th power, which is 32. 2/5 times 32. I don't know, whatever that is. So ... and then find your common denominator to get a nice fraction answer. Okay. This one, again, I'm going to rewrite. This one's pretty similar to the last one. I'm going from 1 to 4. We're going to take the root x into 2. So 2x to the negative 1/2. And this is going to be x squared divided by x to the 1/2 is x to the 4/2 minus 1/2 is 3/2 positive. So that should be plus x to the 3/2. So I then take the antiderivative. I get 2. I'm going to add 1 to that. That gives me x to the 1/2. I'm going to divide by 1/2. Same thing as multiplying by 2. And then I am going to anti-differentiate that. So I'm going to add 1 to 3/2, 5/2, and I'm going to do it times a 2/5. And then let's see, that's a 4 if you want, 4x to the 1/2 plus 2/5 x to the 5/2. Now I am going to plug in, and that should be evaluated from 1 to 4. So let's see, it's going to be 4 square root of 4 plus 2/5, 4 to the 5/2. That's what happens when I plug in 4. And then the 1 should be easy. It's just going to be minus, and then plug in 1 here and here. So that's just going to be what? 4 plus 2/5. Okay. So the calculus is done. Now it's just arithmetic. That's square root of 4 is 2. 2 times 4 is 8 plus 2/5. We just did one like this, right? The 4 to the 5 halves is 32, right? Square root of 4 is 2 to the 5th is 32. So 32 over 1 is what that's going to be. That's what happens when I plug in 4 minus. And then if I want 5 times 5, that's 20 over 5 plus 2 over 5, 22 over 5, 22/5. I don't know, should we finish this one out? You can use a calculator for these if you want. That's going to be 64/5, 64 over 5 plus 40 over 5, 104 over 5. Minus 22/5, and my final answer, if I did my math in my head correctly, 104 minus 20 is 84, minus 2 more is 82, maybe? Sounds about right. How about this, the antiderivative? This one you just kind of remember, you might remember the derivative of the cosecant function is the negative cosecant cotangent. So there's a little trick to this one. So it means the antiderivative, I'm going backwards, the antiderivative of cosecant cotangent would be cosecant x, but I need a negative sign, or if you want, you could make that the derivative and put a negative out there. So then this has the antiderivative of cosecant, and then the negative comes along, constant multiple. And then all I got to do is evaluate cosecant of x at pi over 3 and pi over 6. So what I would do is I'd factor out that first negative. And then I say cosecant of pi over 3 minus the cosecant of pi over 6, which is, right? And if you remember, the best way to do this is to find the sine of pi over 3. The sine of pi over 3 is root 3 over 2, and then take the reciprocal of that, so 2 over root 3. And then the sine of pi over 6 is a half, so the cosecant of pi over 6 is 2. And then what would we do? I don't know, probably this. And then I'm going to have a common denominator of 3. So I end up with 2 root 3 over 3 minus 6. Okay, one more. This should be up here. I think the question was find the area under this thing. So the square root of x goes like this. And if this is 9 and this is y equals 0, it's also x equals 0. So what is the area of this shape? That should be the point input 9, output 3 if we're taking roots. So this area is represented by this definite integral, 0 to 9 root x dx, which is x and 1/2. So I go x to the 3 halves times 2/3, and I plug in 0 and 9. And I don't have to worry about the 0. Did I say that up here? I might have missed that one. Where was it? Oh yeah, this guy. I don't know if I said that. I should be plugging in 0. I plug in the 4 and say minus, and then I plug in 0. But I just realized when I plug in 0, I just get it 0 there. All right, that didn't happen on this example when we had to plug in the 1. We plug in 1, we got these guys. But the same thing goes here. I don't really have to worry about that 0 because it doesn't always happen, right? For example, e to the 0 will give you a value, but an x, a 2/3 x to the 3 halves is just 0, so we don't really have to worry about it. This is my answer. That is the area. If you want, you could say minus 2/3, 0 to the 3 halves, but of course that's just going to be 0. Okay. So what's 9 to the 3 halves? That's the square root of 9, which is 3. 3 cubed is 27. 2/3 times 27. If I'm doing all this right, I think I am. Should give me 18 square units.